How often have you seen your on-call support lead looks like they haven't slept in days or included in an unavoidable outage? You get notified of the outage, you join the call, and they say payments are down again. Now, you would assume that payments are important, so there has to be a big reason for it. Maybe your cloud provider is having a global outage, or maybe your data center burned down, or because some over enthusiastic intern dropped the entire production database. But more often than not, this is not the case. Mostly, it's because of a string, a 64 character API key that was rotated or revoked in the middle of the night and took down half your microservices with it. Later in the postmortem, someone asked the question that should actually be offensive to every modern identity architect. Why are we still running a multi million or in some cases multi billion dollar business on copy pasted secrets in YAML file? And today we are going to answer that question. This is the Identity Navigator, and I am Rohit. And in this episode, we are going to talk about workload identity, what it is, why it matters, how it actually works under the hood, and why it's the only sane way to secure a world full of microservices, Kubernetes pods, CI/CD pipeline, and increasingly autonomous AI agents. By the end of this episode, our goal should be simple. If someone drops SPIFFE, SPIRE, Workload Identity Federation, or SLSA in the meeting, you will not only understand it, you will the one explaining it. So when I was growing up in identity, there were these two peoples who showed up in all the examples. I'm not sure if you have heard of them, but they were called Alice and Bob. Honestly, at one point, when I was thinking about launching this podcast, I was about to name this The Chronicles of Alice and Bob. And I thought, I will try to explain identity fundamentals using Alice and Bob as an example. And I seriously considered that. But then I realized podcasts, they don't show up in feeds or things like this. So that would have been too clever for my own good. Like you don't search an identity podcast and put in Alice and Bob in the search field. So that is how the Identity Navigator came about and not the Chronicles of Alice and Bob. So back to Alice and Bob. In the examples that I was taught on, Alice always forgot her password and Bob always had the right access. And somehow the entire field of identity security and management was built around their extremely dramatic office life. Alice was the user, and Bob was the human and also sometimes service. He was also the server, he was the machine, and Bob sometimes was the thing in the basement nobody talked to unless it needed to print something. This worked and that worked when identity mostly meant humans logging into apps. But all of us know the word has changed. Now the companies aren't just staffed by people, it's staffed by software. So software calling software, pipeline calling clouds, pods calling databases, agent calling tools. So and a thousand little bobs carrying the business on their backs. So let's talk about the real Bob here. Bob is a loyal company employee. Bob shows up early, drinks bad coffee, answers tickets, and never complains. He reads the run books. He gets paged at 2 a.m. and he somehow still says, I'll take one for the team. Bob used to get by with a client secret, or an API key, or a service account credential, or a token stored in Vault. But Bob is tired, and tired Bob is carrying a secret around in a world where secrets leak. So let's start from the basics. In the land of identity, we have human identity. That's Alice. That's Bob, the person. That's Charlie. That's Rohit. They log in with username, passwords, MFA, maybe a FIDO2 key. They get sessions, tokens, and roles. But modern systems are not dominated by humans. They are dominated by software talking to software. That might be a microservices calling another microservices, a Kubernetes pod calling a database, or a GitHub Actions pipeline deploying infrastructure into Azure, or an AI agent calling an internal recommendation API. All of those are workloads, non human software processes that need to authenticate and be authorized to access something. So, here is the first core definition for today. A workload identity is the identity of a software workload, like an app, service, container, script, or pipeline, used to authenticate it to other systems and APIs. So instead of who is this user, the question becomes who is this workload really right now on this machine in this cluster? And that really right now is where things get interesting. So before we go deeper, let's clean up a bunch of terms that people often mix together. Non human identity management or NHIM. Now, this is a broad governance umbrella. It must ask what non human identities do we have? Who owns them? What are they allowed to access? When do they expire? Are they still in use? That's the inventory and governance layer. So, if identity was a city, NHIM would be the records office. Now, you have all heard me or read my thoughts around non human identity management. This is a good concept for talking to the executives. This is a good, broad umbrella term that can be used for governance. But when you start to design and architect your platforms for non human identity management, the things get tricky because every non human identity is drastically different. And this is what we called out in our previous episode of identity categorization done right. There are so many different type of identities, but they should be differentiated or categorized based on their behavior. Otherwise, we just create taxonomic debt. And I think NHIM is actively creating taxonomy debt in many environments today. So if you haven't listened to that episode, I would really advise you to go back and listen to it. I'm sure you would like it. But we are here. And now we talk about API keys. So API keys are the old school ways Bob proves who he is. You give Bob a secret string, Bob presents the string, the system says, yep, that matches. It's simple, it's familiar. Honestly, this is basically from 2000 years, this is the way to authenticate each other. But now we realize that it is also a terrible long term answer. Because if Bob knows the secret, anyone with the secret can be Bob. That leads us to Vault. Vault is the clever butler. It stores secrets, it brokers secrets, it hands out credentials, and it does a lot of heavy lifting. Vault is useful, but Vault is not the same as identity. Vault manages secrets. Workload identity minimizes the needs for secrets in the first place. And then there are cloud native workload identities. AWS IRSA, Azure workload identity, GCP workload identity. These are platform specific ways of doing the same underlying thing. The platform says, I know which workload this is. I know where it is running. I can issue a short lived credential. You don't need to carry a long lived secret around anymore. And then comes the workload identity. This is the modern model underneath all of it. So instead of asking Bob to carry a secret, it asks, who is Bob really? Where is Bob running? What code is Bob executing? What runtime context is Bob in? And can the platform attest that Bob is the right Bob? And that is the shift. So you should ask this right now if you aren't already. Why should you care? If you have built anything in the last decade, you probably already implement workload identity. And some of you must have done it in the worst possible way. I know I have. Because it starts innocently. You put an API key into a configuration file, then into a CI/CD variable, then into a secure password manager that everyone screenshots into Slacks or Teams. At small scale, it feels fine, and then your architecture grows 5,000 services, each with at least a client ID and a client secret. It's well into the five figures of credentials to protect, rotate, and audit. So now you have token theft risk because you must have heard the podcast episode about the bearer tokens, and bearer tokens can be replayed until they expire. You also have a supply chain risk because if CI/CD is compromised, attackers can steal secrets and mint their own tokens. And you have obviously operational pain because teams spend real time and money rotating secrets and fixing outages caused by the expiry. And cloud providers basically admits this in their own docs. Storing long-lived credential secrets is brittle, risky, and operationally heavy. So the why should we care is simple. At scale, manual secrets for workloads do not work. They are too many, too long-lived, and too easy to leak. As we move into a world of ephemeral containers, serverless jobs, and AI agents that can spawn and disappear in seconds, trying to pre assign static credentials to every possible workload becomes literally impossible. We need something better. And that something better is workload identity. You would also hear concepts about authorization layers and some of the new startups creating that as a session broker. And we will deep dive into them in one of the future episodes. But in this one, I really want to talk about the workload identity and did not wanted to dilute the concepts here. So, uh, in addition to Alice and Bob, what else did you always see as an example in your identity books? For me, it was a fictional company called Acme Corp. So, because we are living the nostalgia today, uh, let me tell you a story about this fictional company called Acme Corp. Acme starts with a monolith, a big Java app talking to a database. To call a third party payment API, they store an API key in a properties file, ship it, and done. This is the first era of hard coded secrets. You authenticate by knowing a magic string, and if anyone copies it, they are you. Then Acme modernizes. They adopt microservices and Kubernetes. Good for you, Acme. And now they have 200 services, each needing secrets for databases, queues, and external APIs. And so they modernize again, move secrets into the vault, inject them as environment variables or mounted files, and rotate them more often. Now, don't get me wrong, that's better. But still, long lived credentials, rotation burden, and any process that can read the secret can impersonate the workload. But then Acme gets cloud native and starts using OAuth client credentials. So now each service has a client ID and a client secret. They request short lived access tokens from an authorization server, and they use those to call APIs. Security is better, but the root secret is still a static string somewhere, your client secret or certificate. If attackers steal it from CI, vault, or the code repo, they can continue minting valid tokens until you rotate and detect. In very one of the earlier episodes, I remember we talked about this secret zero problem, and this is exactly what I'm talking about here. That's a turtle on a turtle on a turtle. But then Acme still has more. Acme goes all in on Kubernetes and serverless. And now they've started deploying AI agents that can spawn other agents on the fly. So now the workloads are ephemeral, auto scaled, and created dynamically by other workloads. And for AI agents, potentially changing behavior at runtime. So you can't pre register every possible agent in a directory, and you can't safely ship secrets to every pod that might exist. And that is a crisis that force evolution. Static credentials don't scale to dynamic and agentic workloads. Acme needs a different model. And instead of proving identity by what secrets you know, you prove it by where and how you are actually running right now. And that is the jump to attestation based workload identity. So, we will talk about what good looks like. But before we get there, before we get into SPIFFE and SPIRE, let's just talk about what it is all about. If I say this Kubernetes pod should be allowed to call the payments API, I want to be confident. It's running the image I built and not something an attacker swapped in, right? That is a reasonable ask. And it's running in the right environment. Again, it's got its credentials automatically from the platform based on those facts, and its credentials are short lived and automatically rotated. So if an identity executive or a security executive is asking you to do all of these things, these are pretty rational, right? And that is the promise of a modern workload identity. Strong cryptography, platform issued credentials, short lived tokens, and binding to runtime properties like namespace, image digest, and service accounts. And this basic pattern in their workload identity and federation docs, this is also covered in Microsoft docs and some of the other vendors. This is the basic pattern. That is, prove the workload through trusted runtime context, then exchange that proof for access tokens without a static secret. So fundamentally, workload identity is equal to automatically issued, short-lived, strongly bound credentials for software based on runtime attestation. So now this sounds a mouthful. That is why I wanted to walk you through of I was just asking for it's running the image I built, not something an attacker swapped in, right? So stronger cryptography. And it's running in the right environment, and it's got its credentials automatically from the platform. So platform issued credentials, and the credentials are short lived. So short lived tokens, right? All of those things made sense, but this line itself might sound heavy. Let me let me say it once again. Workload identity is equal to automatically issued, short lived, strongly bound credentials for software based on runtime attestation. Sounded heavy, right? And I know many of you are experts and you would say no, right? But for many of us, it does sound heavy, and that is why I wanted to talk to you about it. It's a very rational ask. So let's talk about SPIFFE and SPIRE. And these are the names people love to drop in architecture meeting. So from now on, you would be a hero in that meeting. So SPIFFE stands for Secure Production Identity Framework for Everyone, and it's the standard. And Spire is the open source implementation of that standard. It acts like the identity provider for workloads. So think of SPIFFE as the passport standard and Spire as the passport office. And at the heart of SPIFFE is the SPIFFE ID, which looks like a URL. It has the trust domain, and the path identifies the workload. So how SPIRE works? Remember, SPIRE is the open source implementation of the SPIFFE standard. So a SPIRE server acts as a coordinator and signing authority. There is a SPIRE agent on each node, and then Aspire also uses workload registration that maps selectors to identifies identities. So workload registration maps selectors to identities, and Aspire uses the workload API to issue SVIDs or SVIDs. Right. So let's talk about the flow because it can get messy real quickly. So Bob starts up. Remember, Bob is a service. Bob starts up. Bob asks the local Spire agent, "Who am I?" I wish I could ask somebody, "Who am I?" But we are we will stick to the topic today. So Bob starts up and Bob asks the local Spire agent, "Who am I?" And the agent checks runtime selectors: pod name, namespace, service counts, image digest, and process context. And the server checks the registration entry, and if the workload matches, it gets an SVID, which may be X509 or JOT. Then Bob can use this identity to do MTLS, talk to other services, or exchange it for cloud credentials. So this is a huge step beyond. Here is a secret, please don't leak it. So how do you translate it into the cloud? Because that is where I believe most of you are working in today. So Microsoft Entra Workload Identity Federation lets an external workload like GitHub Actions, Kubernetes, or another trusted IDP exchange a token for Azure access without needing a client secret. And that is huge because instead of managing a static credential, you now configure trust relationship. You remember the federation concept for the human domains, right? So this is you configuring trust relationship. You have an issuer, you have a subject, and you have an audience. Now AWS the same basic thing with EKS and IRSA. A Kubernetes service accounts can be mapped to AWS permission without a long-lived secret. Sounds nice, right? And then GCP has similar patterns with its own workload identity model. So the common idea is this: irrespective of which cloud platform you are on, the platform issues or trusts a token. Token is short-lived. The workload proves its runtime identity, and the cloud exchanges that proof for access. And that is workload identity in action. But wait, still have more things to discuss in this episode. So when people say cloud workload identity, they are usually talking about platform native federation. When people say workload identity, they often mean the broader runtime trust model. Right. So don't get confused on how these terms are being used in your meetings normally. Now, a lot of these things you would say, I don't hear them in my identity and architecture meetings. I hear about Vault and API keys and cloud services. So let's get a little explicit here, because this is if this is what you hear in real life, this is what we should talk about. So we spoke about non-human identity management that you hear. We spoke about API keys. We spoke about Vault, right? Uh, but I don't think we spoke about AI agents, right? And how can we be in a podcast at about 25, 26 minutes and do not talk about AI agents, right? So obviously, I will not deep dive into AI agents today, but like an ordinary service is predictable, an AI agent is not. An AI agent can typically decide what tool to call. It can change its plan, spawn sub-agents, use new context, and in some cases adapt as it runs. And this changes the identity problem completely, right? So that is why AI agents is a part of workload identity, but there is more to it when it comes to like you'll have to design more controls. So if you don't assign identity to an agent, then you get chaos. And that is why I really like Agent 365, the new solution from Microsoft that went into public preview, I think the start of this month, May 2026. Because you need to assign identity to an agent so that you can do attestations and you can assign accountability. Because without an identity, you can't tell which agent made which call. You can't scope access properly. You can't revoke one agent without breaking others. And you can't audit behavior. You can't govern delegation. So, yes, I really do believe assigning identity to agents is crucial because an agent without identity is just a floating trust problem with a language model attached, and nobody wants that. So, based upon my, I would say still not so much, but I've just been playing around with Microsoft Agent 365. So, the direction really makes sense to me. I know the product has so much more scope to develop. I think it still is like the first version or V1 of it. Also, for $15 per user per month, it is not enough thing for small to medium businesses and mostly for an enterprise. But that direction makes sense to me. Agent needs identity, lifecycle, governance, and policy, just like human users and workloads do. And I'm pretty sure this is the direction the industry is heading. Right? And that is why the identity uncertainty principle is such a powerful idea. And the point that it makes, it's simple, but I would say it's brilliant. As and it the point that identity uncertainty principle, which is the foundational law of agentic AI authorization, makes is brilliant because it simply says as an AI agent becomes more autonomous, static identity confidence decreases. And I really like this because it gets it from a problem and not a solutioning point of view. Like, what is the first thing that is being told to us? Like, define the problem in terms of what the business should care about, right? You cannot lead in with a technical concepts, and that is where I think identity uncertainty principle does a lot of justice to how identity practitioners can frame this problem, right? Because now we are saying your identity or certainty of the identity itself is diminishing exponentially as your agents are becoming more autonomous. And that would lead into the conversation of, okay, I don't want that. So what should I do? And then you can have these additional controls and CAEP and shared signal framework and all the other dynamic controls over that authorization layer come into picture. Because the more the system learns, adopts, and spawns new behavior, the less a one time startup token tells you about what it is doing right now. And it also proves that the point in time authentication is not enough, right? So you can start with that identity and sanity principle and define the controls and can get business buy in based upon how assured or what is the level of confidence that they would like in their identity. So if point in time authentication is not enough, you would also need initial attestation and continuous monitoring and dynamic revocation or kill switch and request by policy evaluation. And that is why workload identity is necessary but not sufficient for the most advanced AI system. Because for systems like these, you need identity plus behavior, identity plus observation, and identity plus policy. So let me give you a, a clean maturity model here. So level 1 was hard coded secrets. Level 2 was centralized secret management, right? And I'm intentionally keeping it at a high level because you should be able to tell at what level your company operates just by listening to it and not after a 6 weeks engagement by a consulting firm. So Level 3 is OAuth client credentials and token based authentication. And I know a lot of you are stuck here. And level 4 is attestation based workload identity. So your SPIFFE and SPIRE, your AWS IRSA, your Azure workload identity, your federation, and your short lived credentials. And level 5 is your continuous behavior attestation. So your signed builds, SLSA provenance, runtime monitoring with eBVF or Tetragon or Falco, policy engines like OPA, and just-in-time revocation. So for level 4s and level 5, that is why let me add just one thing to it. Level 4 answers who is this workload? And level 5 answers, is this workload still behaving as intended? And that is a major jump. So let's briefly unpack the level 5 pieces. Sigstore and cosign, right? These are used to sign artifacts at build time so you can prove the image came from the right pipeline. And SLSA formalizes the trustworthiness of the supply chain. So your build is recorded, it is isolated, your source is controlled, your provenance is captured, your reproducibility is improved, right? And then there are also in level 5, you have eBPF or Tetragon, Falco, and Keylime to monitor your runtime behavior. And they watch syscalls and file access and network traffic and suspicious deviations, right? And all of us use pback in some way, form of another, or OPA, right? So policy engine like OPA enforces authorization at request time. So now your architecture should all come together, and it will have a trusted origin, a trusted runtime, a trusted behavior, and a trusted decision. And this, my friends, is the future of secure AI and secure workloads. So let's get back to Bob. Rob started as a tired employee with an API key. Then Bob gets a client secret. Then Bob gets Vault. Then he gets Cloud Federation. Then he got attestation. Then he gets short lived credentials. Then he gets monitored. And then he becomes a trusted workload. And that is the hero's journey. Bob did not become the hero because he memorized the secret. Bob became the hero because the platform finally stopped making him carry one. And that is the point of workload identity. So, if you're trying to push this in your own company, here is how I would do it. Start with the pain, show the secrets ball. How many secrets, how many pipelines, how many manual rotations, how many incidents. And then start with low regret wins. Move CI CD to federation. Move Kubernetes workload to cloud native workload identity. And these are easy wins because the vendors already support them. And then introduce SPIFFE and SPIRE and start in one cluster. Don't go big bang, right? Demonstrate registration and attestation and SVID insurance and issuance and MTLS and workload to workload identity trust. And then prepare for agents. Uh, Define identity, policy, lifecycle, delegation, monitoring, and revocation. And don't wait until the agents are already in production and asking other agents for access to things they should have never seen. So let's rewind the whole episode. We started with Alice and Bob. Alice was the human and Bob was the workload. And then Bob grew up. Bob became a service. Bob became a pod, became a cloud workload and an AI agent. And suddenly the old word of static secret stopped making sense. Okay. So we need a new model. Non-human identity management for governance. Don't use it to architect your platforms. Vault for secret brokering. Cloud native federation for platform trust. SPIFFE and SPIRE for workload identity. SLSA, cosign eBVF, OPA for continuous trust, and agent identity for the AI future or AI present. If you remember one thing from this episode, remember this. Workload identity is the modern way for software to prove who it is without carrying a reusable secret like a bad habit from the old world. That is the shift, and that is the future. I'm Rohit, and this is the Identity Navigator. And next time somebody says, "Can we just put the secret in Vault?" you will know exactly what to say. Please let me know how you felt about this episode. You can always email me or find me on LinkedIn. Both of these contact details I will put in show notes. Thank you so much for listening. This is Rohit, your Identity Navigator.